Hi guys, I thought I'll make a quick video on recrystallization, which is the step which happens after crystallization and filtration. So just to remind you of the different steps for making aspirin, to begin with we have reflux, where we heat the reactants together, then we crystallize it to form the aspirin crystals, and then we filter it to get the aspirin crystals in a solid form. Now after that we need to go through something called recrystallization. So you might be thinking, we already did crystallization where we make the solid aspirin crystals. Why do we need to do recrystallization? Now, one thing that you need to know is after we crystallize it, once we get the solid crystals, and then we filter it to get rid of any liquid impurities, that aspirin is still not fully pure. Okay, obviously we can't get 100% pure aspirin. That's very unlikely. However, what we need to do is then recrystallize it to make the aspirin even more pure. So after reflux, crystallization and filtration, what we have is something called crude aspirin. So crude aspirin is aspirin with a little bit of impurity, okay? So what we then need to do is we need to dissolve it in a solvent. So we use ethanol and water. Now the solvent that we use could vary depending on what we're making, but for aspirin it's ethanol and water, okay? So what we want is, for recrystallization, we need to select a solvent which will allow the aspirin to dissolve in it at high temperatures, but then crystallize again, recrystallize at lower temperatures. So what we do is we get the crude aspirin, which we collect from the crystallization and the filtration after crystallization. We get that crude aspirin, we dissolve it in a conical flask, we add ethanol and water, then we heat it so that when the temperature increases, solubility increases, and the crude aspirin will dissolve, okay, in that solvent of ethanol and water. After that we cool it, okay, and when we cool it, the aspirin will recrystallize, it will form the crystals again, okay. Now the reason why we do recrystallization is because we only want the aspirin to crystallize, and we don't want any impurities or unreacted reactants to also recrystallize, okay? So we select a solvent where the aspirin will recrystallize when the solvent is cooled down, but any impurities will stay dissolved in the solution, okay? So it's really important that we select the right solvent. So the solvent that we select should basically allow the product that we're making, which in our case is aspirin, to dissolve when it's heated, but then recrystallize when it's cooled down. Okay, therefore we'll have a lower solubility in the solvent when it's cooled down. But the solvent should also be a solvent which will allow any unreacted reactants or impurities to stay dissolved when heated and also when cooled down, okay? So it's really, really important that we select the right solvent for recrystallization. And then after that, by the end of recrystallization, after that we filter it, and then we should get pure aspirin crystals. And then we can test it using things like infrared spectroscopy, or we can use melting point measurements to find out the purity of the aspirin that we have made, okay? So the recrystallization process is really important. So it's not just like us doing the crystallization again, it's we need to select a really good solvent, and there are two roles of the solvent, like I mentioned before: allow the product to recrystallize, but also keep the impurities dissolved. So those are the two roles of the solvent which we select for recrystallization. But yeah, I hope that helps. So after that, after recrystallization, you obviously filter it again, and then that's when you do the tests. So again, we do vacuum filtration after recrystallization, and then you do the tests such as IR and melting point measurements.